Alright, good morning class. Mr. Strubin speaking here. Now it's kind of weird. You listen to my voice, me not being here. Trust me, it's more weird for me teaching to an empty classroom right now. People out in the hallways seeing me talk to myself think I'm a huge weirdo. So let's get beyond the weirdness and let's get down to work. At this point, you guys should have checked your answers with the answer keys passed out by the substitute teacher. So let's go over a few problems from last night that I believe you probably had some issues with. The first one you see on the board is number 7. Remember, our goal is to always get like denominators. Once we get like denominators, it's as simple as adding or subtracting like we did last week. Before we get like denominators, we want to look for our LCM. But even before that, we want to see if we could cancel some stuff out, simplify our fractions, make life a little bit easier on ourselves. So if you look at that first fraction, we have 6 over 3. We could reduce that to 2 over 1. M and M cancel, and on the right fraction, the 4 over 6 reduces to 2 over 3, and the M's cancel as well. Let's just clean that up and write what we have now. 2 over n squared plus 2 over 3n. Okay, now we want to ask ourselves, what is our LCM? Every single factor must be represented, and every variable to the highest exponent also must be represented. So if we're looking for our LCM, like I said before, each factor must be represented. We have a 3, and we have the variable n. Remember, to the highest exponent. So our LCM is 3n squared. That's going to be our like denominator. So here is what we have at this point. We ask ourselves, what is missing in each denominator? What is missing to get our LCM? In our first denominator, we have n squared. Our goal is to get a denominator of 3n squared. So we multiply our bottom by 3 and our top by 3. Over on the right fraction, what is missing? We have 3n. We must reach 3n squared. So we multiply our denominator by n and our numerator by n. Now let's just clean that up. Okay, now we have like denominators. All we have to do is add our numerators. 6 plus 2n all over 3n squared. No like terms combined at this point, but we can factor out something from our numerator. And that is a factor of 2, leaving us with 3 plus n all over 3n squared. Make sure there's nothing else that can be factored or simplified. As you can see, nothing else can be simplified. Here is our final answer. Any questions on number 7? Just kidding, cannot answer. I'm not here. This is just my ghost. Let's move on to the next one. Alright, here next we have number 19. A little bit more difficult of a problem, but remember, before you even start looking for a common denominator, looking for that LCM, see if you can cancel anything. Looking at that first fraction, our 6's gone. M on top gone, leaving us with m squared on our bottom. Let's just clean that up. Our rational expression now reads 1 over m squared plus 5m all over m squared minus 9m plus 18. Okay, before we can find our LCM, we must make sure each denominator is factored. Cannot factor our first fraction, but the second one can be reverse FOILed. We need a product that'll give us 18, or a sum that'll give us a negative 9. The two numbers should be a negative 6 and a negative 3. Okay, now we can figure out what our LCM is. Remember, each factor must be represented. We have an m squared, we have an m minus 6, and we have an m minus 3. Okay? Now we must multiply each fraction by the missing factors. So let's just rewrite 1 over m squared. In a second, we'll multiply it by what's missing. Same with our second fraction. In green, we'll multiply both our numerator and our denominator by the missing factors. So in that first fraction, we have m squared only. We must multiply our numerator and our denominator by the two missing factors, m minus 6, m minus 3. Looking at our second fraction, we have m minus 6 and m minus 3. The only factor missing is that m squared. So we multiply both numerator and denominator by m squared. Now let's just simplify, clean up each fraction. M minus 6 times m minus 3 times 1. Well, we already knew from before that m minus 6 times m minus 3 foils to m squared minus 9m plus 18. And that's all over m squared times m minus 6 times m minus 3 plus 5n times m squared, 5m to the third power, all over m minus 6 times m minus 3 times m squared. And remember, the order of our denominators does not matter, because addition, and in this case multiplication, always commutative. So the order, even though they are not in the same order, that's fine. At this point, we have like denominators. We can combine our two numerators. So we have m squared minus 9m plus 18 plus 5m cubed, all over our like denominator, m squared times m minus 6 times m minus 3. Check your numerator, see if anything can combine, any like terms. As you can see, nothing can combine. If anything, we can write that numerator in descending order. So 5m to the third plus m squared minus 9m plus 18, all over m squared m minus 6 times m minus 3. Okay, we're going to go through two more homework examples. The third of the 4 homework problems is number 21. Remember, look at each fraction, see if anything can cancel. Unfortunately, nothing cancels in either the first or the second fraction. So what do? We want to factor now. Oh, I take that back. Something does cancel. Look at the first one. X and X. Those are gone, so we're left with 3 over 5 plus 6 over x squared minus 36. Now that we simplified each rational expression, let's factor, let's find our LCM. Cannot simplify or factor the first. The second, x squared minus 36, that's a difference of perfect squares. X plus 6, x minus 6. Okay, now that everything's factored, we have to look for that LCM, that least common multiple. Well, we have 5, we have x plus 6, we have x minus 6. We combine all 3 of those factors for our LCM. So 5 times x plus 6 times x minus 6. Okay. So what's missing? I'm going to combine steps from the previous examples. What's missing in that first fraction? We have a denominator of 5. Our goal is to get a denominator of 5 times x plus 6 times x minus 6. Therefore, we multiply both the top and the bottom by x plus 6 times x minus 6. Looking at that second fraction, 6 over x plus 6 times x minus 6. What is missing? The only factor missing is 5. Multiply our numerator by 5, multiply our denominator by 5. Let's just clean that up a little bit now. 3 times. Let's go ahead and FOIL that to x squared minus 36 and that is all over 5 times x plus 6, x minus 6, plus 6 times 5 gives us 30, all over 5 times x plus 6 times x minus 6. Okay, now that we have our like denominators, actually, before we combine these, we still have to simplify that first fraction a little bit. Let's distribute that 3 to each term inside our parentheses. So we have 3x squared minus 3 times 36 gives you 108 plus 30. Because they are like denominators, we can combine those right now. So 5 times x plus 6 times x minus 6. Okay, at this point, we want to combine like terms. So we have a negative 108 plus 30. That gives us 3x squared minus 78 all over 5 times x plus 6 times x minus 6. Let's see if anything simplifies. Cannot factor anything out of our numerator. Denominator is factored. Therefore, this is our final simplified answer. Okay, the last problem we're going to go through from last night's homework is the last problem, number 22. So, nothing we can cancel at this point or simplify it. So let's go ahead and factor our denominator from our first fraction. 4x over our GCF of 2 times x plus 3 plus 4x over x minus 4. As you can see, the 4 and the 2 can reduce to 2 over 1. Now our rational expression reads 2x over x plus 3 plus 4x all over x minus 4. Simplified each fraction as much as we possibly can. We factored each fraction. Now we want to look for that LCM. This one's actually not too bad. We have two fractions, x plus 3 and x minus 4. Those two factors combined will make up our LCM. So x plus 3 times x minus 4. Looking at that first rational expression, we have a denominator of x plus 3. Ask yourself, what is missing? The other factor of x minus 4 is missing. And our second fraction, we have x minus 4 in our denominator. What's missing? X plus 3. This is what we have right now. 2x times x minus 4 plus 4x times x plus 3 all over our like denominator of x plus 3 times x minus 4. Let's go ahead and simplify our numerator by distributing our two factors outside the parentheses. So 2x times x gives us 2x squared minus 8x plus 4x squared plus 12x. Okay, at this point we want to combine our like terms. So I see 2x squared and a 4x squared giving us 6x squared, and I see a negative 8x plus 12x giving us positive 4x all over x plus 3 times x minus 4. Now make sure everything's simplified before you decide this is your final answer. So you can see our numerator, we can factor something out of that numerator, and that would be a 2x. When we factor a 2x out, we are left with 3x plus 2 all over x plus 3 times x minus 4. Is there anything else we can simplify? I do not believe so. Let me extend the page so we can see our final answer. We have 2x times 3x plus 2 over x plus 3 times x minus 4. Okay, so hopefully that clears up at least some of our questions from last night's homework. Let's try to do a few new examples. So at this time, you just take out some loose leaf paper or put this on your homework from last night's, or on the back of your homework from last night, and let's copy this first example down. Okay, we'll do this one together. and then examples 2 and examples 3. I'm going to give you guys a few minutes to do each, and then we'll check our work with my work on the board. Okay, so in example 1, let's see if anything simplifies before we factor. I see that 2 and the 4 reduces to 1 over 2. X and X simplify. Over on our second fraction, X and X cancel, so let's just clean up what we have. 1 over 2 times Y plus 3 over 2X. Okay, nothing else can be simplified, nothing else can be factored. At this point, let's look for that least common multiple. We have a factor of 2 in each, so that must be represented in our like denominator, and we have a factor of Y and we have a factor of X. Therefore, our LCM is 2 times X times Y. Let's ask ourselves, what's missing in our denominator in that first fraction? Well, we have our 2, we have our Y, we're missing that X. That is what we multiply each our numerator and denominator by. Let's check that second one. We have 2x in our denominator, 2 and x are taken care of. There we go, 2 and x. The last one missing is that y. So we multiply each numerator and denominator by y. Let's clean that up. 1 times x gives us x plus 3 times y, 3y, all over 2 times x times y. Let's check, can anything simplify? No combination of like terms, no factoring. Therefore, this is our final answer for number 1. Okay, here's number 2. So I'm going to give you guys a second to copy this one down and also a few minutes to solve it, okay? Remember, before you even start factoring or looking for that LCM, you want to try to simplify anything that can be simplified. I'll give you guys a hint. If you look at that 3 over 6, we know that can be reduced to negative 1/2, okay? So let's then reverse FOIL that denominator in our first fraction and find our LCM. Okay, let's see where we're at. Let's reverse FOIL our denominator, x and x. Let's try a positive 5 and a negative 1, minus 1 over 2. Okay, everything's factored. Nothing else can be simplified. Let's look for our LCM. So we have a factor of 2, we have a factor of x minus 1, and we have a factor of x plus 5. In that first fraction, what's missing? Well, we have our two binomials. The only thing missing is that 2. So let's multiply both our top and bottom by 2. In our second fraction, the only one we have is 2, so we have to multiply our two binomials to each our numerator and our denominator. So let's go ahead and clean this up, put it under one fraction. So we have 2 times 6x minus 1 times x minus 1 times x plus 5 all over 2 times x minus 1 times x plus 5. Let's distribute 12x minus, well, we knew before that x minus 1, x plus 5 are two factors of the trinomial x squared minus 4x minus 5 all over 2 times x minus 1 times x plus 5. Okay, once again, we have to simplify our numerator. So 12x, let's distribute that negative, changing all of our signs. Minus x squared plus 4x plus 5. Okay, at this point we can combine like terms. Let's try to write this in descending order. I have a negative x squared first. 12x and 4x will give me a positive 16x. And we have just our positive 5. All over 2 times x minus 1 times x plus 5. Okay, that trinomial in our numerator will not reverse FOIL. There is no possible combination that will give us a product of 5 and a sum of a positive 16. What we can do is factor out that negative 1 because we don't like our leading coefficients to be negative. So x squared minus 16x minus 5 all over 2 times x minus 1 times x plus 5. And this now is our final answer. Now I did make one minor mistake looking back at my work. Let's see if you guys can find it. I'll give you about 30 seconds to look, see if you can find my mistake. Came in this step right here. If you look in parentheses at trinomial, what did that reverse FOIL to? It did not reverse FOIL to an x squared minus 4x minus 5. It reversed FOIL to an x squared plus 4x minus 5. Therefore, our signs must change in our following steps. So plus a negative 4x, that would make this a negative x squared plus, if we combine our like terms, 12x and a negative 4x. That won't give us 16x. Instead, that's going to give us an 8x. Minor mistake, and clean it up right here. So our final answer should be a negative 1 times x squared minus 8x minus 5 all over 2 times x minus 1 times x plus 5. Okay, final example, example number 3. After this, the substitute teacher will pass out your homework, and hopefully you guys will have a little bit of time to at least begin the homework. Now be careful. Once you're writing this one down, as you can notice, that's a subtraction sign in between. So you have to make sure that negative does get distributed to your second fraction. I'll give you guys about 3 minutes to begin this problem. Okay, I started the problem for you guys. I simplified the first fraction, I simplified it 2 over n squared, and I reverse FOIL that trinomial, n squared plus 9n plus 18. It reverse FOILs to n plus 6 times n plus 3. Okay, now it's time to find our LCM. We have an n squared, an n plus 6, and an n plus 3. Those three factors combined will give us our LCM. So what's missing? We only have an n squared in the first fractions. We multiply by the two binomials, n plus 6 and n plus 3. N plus 6 and n plus 3. In our second fraction, the only of the three factors we're missing is n squared. So we multiply each our numerator and denominator by n squared. So let's try cleaning this up a little bit. It's going to take us a few steps to simplify. So we have 2 times n plus 6 times n plus 3. I'm going to write this as minus n squared. Put that missing third factor in front, times 4n plus 1. All over our common denominator of n squared, times n plus 6 times n plus 3. Okay, let's FOIL that first product of two binomials. We know from the beginning of the problem that FOILs to n squared plus 9n plus 36. And let's distribute that negative n squared. giving us a negative 4n cubed minus 4, excuse me, minus n squared, not 4n squared, only n squared, all over n squared times n plus 6 times n plus 3. Okay, still not done simplifying. Now we have to distribute our 2 to each term. So 2n squared plus 18n plus 72 minus 4n cubed minus n squared, all over n squared times n plus 6 times n plus 3. Okay, almost there. Last step is to combine like terms. Let's go in descending order so we don't miss anything. Negative 4n cubed. That'll go first. I see 2n squared and negative n squared, giving us a positive n squared. So those are gone. 18n and 72. Last two terms, all over n squared times n plus 6 times n plus 3. Okay, nothing else is going to factor out of our numerator. Let's call it a day. There's our final answer. Alright, well that's all I have for you guys today. I'll be back in school tomorrow. If you have any questions, shoot me an email. I'll also be here early in the morning tomorrow, 7 a.m. To clear up any confusion on tonight's homework. Alright? Have a good... No, you know what? Have a great day. See you guys tomorrow.